Okay, this is Mr. Peterson, and I'm going to go through the notes for section 3.1 in Algebra 2. And in this section, we're going to be learning to identify what's called a monomial and later a polynomial expression. And then we're going to classify them by the number of terms that each of them has, or we're going to classify them by something called their degree. All of these are what I'm going to be teaching in this section. You're going to learn how to write a polynomial in standard form. And then you can predict the end behavior. Does the right arm go up or down? Does the left arm go up or down? And then you're going to calculate the maximum height or the minimum height on these functions when you graph them. Okay, we're going to start with a definition here. We're going to look at a monomial. And a monomial can be a variety of things. It can be a single number or just a variable. Or it can be a product. Product, you'll remember, means multiplication of a coefficient number, excuse me, and a single variable or a string of variables. But this is the takeaway. You have to multiply them all. And I'll show you examples of monomials down below. The glue that holds them together is always multiplication. Okay, the length of the variable string, so if you have three variables, x, y, and z, all multiplied together, that length is called the degree. So three variables multiplied together, they can be different, like the example I just gave, x, y, and z, or they can be the same, x times x times x. That's called the degree, and it's degree 3 when there's three of them. An example of degree 4 would be x times x times x times x. All right, so let me give you some example of monomial expressions. And you'll see this first one here. Negative 15 times, indicated with a dot, x times y times y times y. Usually we write this in a more condensed version using exponents. So negative 15 x to the second power times y to the third power. The coefficient is that front number, the known number, so the coefficient is negative 15. And the degree of this polynomial, let me show you here, is the length of the variable string that's multiplied. So there's 1, 2, 3, 4, 5. The degree of this one is fifth degree. Now you could figure that out here by adding those exponents, since there's two x's and three y's. But we usually use the letter n to indicate the degree. So this one has a degree of 5, n equals 5. Okay, in the next example, you can see all these multiplications here. That's what makes it a monomial, is all the multiplications. And there's 1, 2, 3, 4, 5, 6 x's. So that's going to be x to the sixth. And y to the second, you can see that there's y times y at the end there. And the coefficient is not shown, but you can always interpret it as being 1. So the coefficient is 1. So there's like a 1 in front there that is also multiplied by that. And the degree is going to be 8. And that's because there's 8 variables all multiplied times each other. You can find that degree looking here by saying there's 6 x's times 2 y's, so a total of 8 variables multiplied all the way down. You don't count the coefficient number in front when you do this. Okay, the next one here has only one variable, just x. So there really is no condensed version. I'm just going to copy the original here. The coefficient here is a decimal number, negative 1.8. And the degree, there's only one variable, so the degree is 1. Okay, the next one is just a constant, 3/5. And you can write it as 3/5 times x to the 0 if you prefer. And that's maybe you learned in previous course, anytime you have x to the 0, it's just the number 1. But normally we don't bother to do that. So the condensed version is just 3/5. That's just the number, 3/5. And the coefficient is also 3/5. And there's no variables. Remember I put an x to the 0 power there. So n is equal to 0. That's a degree of 0. Okay, we've got the same type of information here, except that we're starting out with a condensed version. All right, the coefficient here is 6. And if you write this out the long way, it's 6 times, and then we have m times m times m, and then times t times t. And if you count that, there's 5 variables in a row. So the degree n equals 5. This one's 5th degree. Okay, so this next example here, we have to have a degree of 0, which means you're not allowed to use any variables. So the coefficient is all we have, 118 and 118. There's no variables. If you prefer, you can write this x to the 0, but since x to the 0 is just the number 1, then we're saying 118 times 1 there, and normally we just write it as 118. Okay, down here it says we have to have 3 variables. They don't necessarily have to be the same. I'm going to use n, and I'm going to use y for this. So I'm going to say y times y times y. And that would be y to the 3rd, but we have to have a coefficient of negative 4.5. So let's put that in front here. And that line is done. Okay, again, what makes these monomials is that there's all these multiplication dots here. That's what makes these monomials. So you can think of a monomial as being a bunch of variables or numbers that are all simply multiplied together in a big pile. All right, a monomial can be put together with other monomials to make what's called a polynomial. And it's important to understand one thing about this here, but a poly means many, but a monomial is also a polynomial. So if you have more than one of them, it's a polynomial. Poly means many. But if you have one of them, it's also a polynomial. So we just had a bunch of monomials up there, and those monomials are also called polynomials. But when you add or subtract 2 or more of them together, it's a polynomial that consists of several put together. So you could think of it as a little bit like this. If we have a bracelet with one bead on it, it's still a bracelet. But if you string a bunch of them together, it's a different sort of bracelet, but it's still a bracelet. And the word here is polynomial when you put them together. And you put them together by adding or subtracting. So here's our first example of a polynomial, and this is one where we're adding 6x to the 4th, adding 3x cubed to it, and negative 8x squared to it, and x gets added, and then finally negative 13 is subtracted. So there's all these different monomials. If you'll think of writing that one out, that would be 6 times x times x times x. So that's a monomial. It's held together with just multiplication. But then all of a sudden that addition comes along and you're starting the next part of it. So let me separate the different parts of this polynomial. And these are the individual monomials. There's 6x to the 4th, 3x to the 3rd, negative 8x squared, just 1x or just x, and then negative 13. And that's the individual monomials in that larger polynomial. Now, when you put these together, you want to collect all of your like terms, all of the ones with the same variables and the exponents that go with them. So, for instance, this part here has an x cubed, and later on you see another part with an x cubed. So you put those together and you go 8x cubed minus 1x cubed is 7x cubed. And I'm just going to go ahead and write what this is over here. The next part you want to look at is this 3x squared. Combine that with this minus 6x squared. And that gives minus 3x squared. And then we'll put the terms with x's in it, this one here and that one there. And when you combine those like terms, you get minus 1x. So let me catch up down here. The individual terms are the individual monomials. And then finally we have this constant right here and this constant right here. And when you add negative 9 and 15, you get 6. So you can see that I've simplified it like that. And then I've separated it into the individual monomial parts. All right, next we're going to learn how to classify it by its number of terms. So when I do this, I like to start with ones that you're more familiar with. So I'm going to start at this middle one here. And it's got 3 parts to it. You've got the x squared part. You've got the term with just x in it. And you've got the constant number 5. And when you have 3 terms, 3 monomials, it's called a trinomial. Taking away one of those, so now I only have 6x and negative 5. Now it's just a binomial. Bi means 2. And when there's only one term, like this constant negative 5, it's called a monomial. Okay, so these prefixes, mono, bi, and tri, are just 1, 2, and 3 in Greek. So you can think of it as a 1z, a 2z, and a 3z in some ways here. Now, once you get above 3, there's no special names. So this next line here that starts out with 4x cubed and then has those other ones, let me write all the individual monomials out here. When there's 4, you just say a polynomial, you can abbreviate, with 4 terms. And the next example is a polynomial with 5 terms. One quick way to see the terms is to put slashes in front of the plus and minus signs. And you can see them all separated now. X to the 4th, first term, 4x cubed. You could write that out with multiplication. That's what makes it a term. Negative 3x squared here, and finally 6x and negative 5. So this one is a polynomial, you can abbreviate, with 5 terms. So we have 3 special names, monomial, binomial, and trinomial, and above that you go generic. All right, like terms can be combined and should be combined before you classify them. At first glance, you would think, boy, that's an awful lot of terms, and you might be tempted to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms. Let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms, and call it something ridiculous like a decanomial or something. But you should combine your like terms first. So start with the highest exponent, 6x squared, and 5x squared is 11x squared. One more is 12x squared. 12x squared minus 4 is 8x squared. And then you're going to collect your x's. Minus 4x plus 6x is 2x. 2x plus 10x is 12x. And finally, the constant numbers, negative 2. Negative 4 is negative 6. Negative 6 plus 9 is 3. So plus 3. And at this point, you judge how many terms there are. Let me list them separately. Here's the first monomial. And you may hear me interchange the word terms and monomials. Terms are parts of an addition problem, and since that's what tells you, the additions and subtractions tells you when a new monomial is starting, you'll hear me call them either terms or monomials. All right, so we had 3 of them. That makes this a trinomial. And to finish out page 2 here, I'm just going to classify these three down here. There's two terms here, and you got to look and see if they're can be combined. These can't, so this one is a binomial. The next one has three terms. I've separated them here. That's a trinomial. And then look carefully, make sure there's nothing that combines with any of these. They can't. There's a fourth power here, but nowhere else. There's a third power here, but nowhere else. Second power is unique. First power on the x is unique. And then we get the constant 19. Nothing can be combined. So then I'm going to count here. There's 1, 2, 3, 4, 5. This is a polynomial with 5 terms. So I'm going to pick up on page 3 in the next video, and we'll break it up 1 or 2 pages per video, and that'll make it a little bit less viewing each time.